Welcome to Data Analysis with Python. Today we move on to advanced Pandas techniques and optimization. And after this, of course, we'll be going to talk about data visualization using for Matplotlib, Seaborn, and maybe some other ones, probably Plotly. Or by the way, there are other ones as well. When we get there, I'm going to introduce them, even if we don't touch them. All right. So as usual, you know that before you even start the course, if this is your first time, you need to be aware that you can check the description box and you have a link there that leads you to where all the materials for this playlist, you can find them, all the data sets, even these code sheets. So what I advise is the best way to learn coding, anything that has to do with coding, is to actually code. So it's better you download the materials and if you look at the first video, I have the description there, the first description box for the first video in this playlist, how you can install a Jupyter notebook that I use to teach. So so you can follow along. So as I'm doing this, you're also doing your own. So at some point, you may have to pause and then try to tweak some things, change some values, and from there you can see the changes that occur, and then from there you learn a lot. So again, the focus is on advanced pandas techniques and optimization. And advanced pandas techniques and optimization simply they actually make pandas code faster, more efficient, and easier to read. Of course, the whole idea of the optimization is, maybe what you can do in 21 lines, you want to do in 5 lines or 3 lines or something. So you just want to have smarter ways of going about what you do. So of course, the first thing we want to do usually is to upload your data. So, and I've described several ways of uploading data. You could type in your data, form data right on the in your in the Jupyter Notebook cell, by using dictionaries involving lists and all that, right? So you could also get inbuilt data sets in Python accessible through different libraries like Seaborn or scikit-learn and all of that. Then you could also get external data sources, like maybe from Kaggle, or somebody sends you a data set or something like that. So today I'm working with the customer behavior data set, which you can find. You find that in the it's of course everything you're doing, all the data sets and everything should be in the same folder for them to be accessible. So I'm using the customer behavior folder. So as usual, I've always advised that anytime you have any data set, you want to check it in its original form. If you have an Excel file like this one is, you want to check the Excel file on its own. So see what it looks like. There are some things you may just do there before you even begin to delve into the data set itself. So here I have this customer behavior data set, and it has 6 columns: customer ID, age, gender, purchase frequency, average spend, loyalty program member, So we have a customer behavior data set right here that we're working with. So now, because it's an Excel file now, in this case, I'm using Pandas, which is for data analysis. I'm using numerical Python, which is for computation before we do analysis. And we are using Seaborn because we are going to do some kind of visualization. And we are just like Matplotlib also. Seaborn cannot operate without Matplotlib. So Matplotlib can stand on its own, but Seaborn cannot stand without working with Matplotlib. So anytime you see Seaborn, you must see Matplotlib. Okay. So the data set. Okay, it's not random, so I just remove this. So I'm dealing with an Excel file, which is customer behavior.xlsx. So, and the way to read that, which was one of the earlier things we learned, is to say read Excel, which is a function in Pandas, which has been uploaded as PD, and then you read the customer behavior file. So df head 50 shows us 50 is the maximum number of data points you can see in Jupyter Notebook. That's why I just use df.head 50. So when I run this now, it shows us the top 50 data points here. So that one we just saw now, I think it's a total of 70 there originally, right? So if you want to see everything, if you want to see the dimension directly, right, you could just do this. So so this one shows the top five, but it doesn't say the rest. Let me let me just do df on its own, yeah. Okay, good. So it shows us. So if you just do df, you get the first five and the last five. and it shows us 70 rows and 6 columns. And then we have all the information like we saw in the Excel sheet. So now this thing you saw, the one you saw in Excel is different from this in the sense that this one is now a Python, a Pandas data frame, which we call DF. So this is now a Pandas data frame. So with this DF now, you can do whatever you want to do with this DF. As usual, right? You also want to have an overview of the data set. Like you want to get the info, you want to see number of columns, number of rows, which we have seen. But when you have very bulky, very large data sets, it's difficult to see the number of rows and columns at once. So of course you would have seen it here, right? But maybe you just want to just want to focus on them a bit more. I forgot as usual to expand, right? This is the first thing I ran. Okay. This is the first thing I ran. And then this is what we had for the data set. And then for data.info, right? Just control enter or shift enter, you get this. So it tells us we have 70 entries. That means 70 data points numbered from 0 to 69. Since Python numbering starts from 0, and we have total of 6 columns. That was obvious when we checked at first, numbered from 0 to 5. Customer ID is an integer, age is an integer, gender is object, purchase frequency is object, average spend is float, loyalty program member is Boolean. So of course, we talked about the variable types already. Object is more like a categorical variable. Integer and float are numerical variable. And then Boolean is Boolean variable, like where you have true and false kind of things. So we have one Boolean, one float, two integers, and two objects, and the memory usage is 2.9, roughly 2.9 kilobytes. Okay. So here we want to see the data description. So the data description, just like you know already, it's one of the things you do for when you're trying to do exploratory data analysis. Describe, actually shows you the statistical overview of the numerical variables. So up here already, we've seen that all these numerical variables, now all these integers and floats, customer ID, which is categorical in a sense, but the way it appears right now, it is actually showing as integer, which is okay. Age is properly numerical. Average spending is also properly numerical. So this describe is just going to focus on all those things that are numerical in nature. So if I do Control Enter, so you see it just extracts only the numerical components, and this gives us an overview of the data. So here you can know the minimum amount somebody spend, the minimum age of those of the customers, right? So 70 counts, so there's no missing data because all the counts are 70 all the way. So the customer ID, we don't have to worry about that because it's categorical in a sense, but it's just showing up here because it's like an integer. So we can even convert it, just like I said in earlier videos. So the mean age of the customers that patronize the shop is 40 and all that. So if you're selling something, you want to sell something that appeals to people who have an average age of 40. The average spending is 258 maybe dollars or whatever the currency may be considering. And then you have the standard deviations for age and average spend. The minimum age of people who come is 19. So if you have things for okay, well, I mean, it all depends on the kind of thing you sell and all that, how appealing it is for the people that come. So you know the minimum age is 19, and the average spending, I mean the minimum average spending is 27.9, and you have the percentile. The maximum age is 64, right? So you're catering to active people. People work, catering to people who are actively working because 18 to 65 in most societies are the active working class. So you want to be sure that whatever you're selling appeals to them, right? Then the maximum average spending is 493, whatever. Okay. So now, since we're talking about optimization and everything, so let's look at loops versus vectorization. Now, in previous videos, we had considered while loop, for loop, and everything. And we talked about iterables too. So you can loop through strings, through lists, through tables, and things like that. But then we come here, and since you are doing something more advanced, we are looking for better ways of doing things, right? So when you look at loops versus vectorization, so if you have a loop-based approach to whatever you're doing, it is inefficient. It's a problem because using loops means slow. Of course, you may not see the slowness except especially when you're not dealing with very large data sets. But technically, that is it. And when it comes to time, there's something in algorithms called time complexity. Is it time complexity? I think it should be time complexity, like how fast does it go? So this is slow because it's the big O of n and it is inefficient. So then df.at, which is involved in looping, causes repeated input and output Python overhead. So that makes it slow. So you may not appreciate that if you are not using very big data, or you're not into the systems, the memory usage and things like that of a computer. But all the same, it's really important. Now look at here. Now we're trying to do so we want to create a new. So far, we don't have any column for high spenders, right? This is the whole thing. We don't have any column for high spenders. So, uh, more like we want to create a column for high spenders, and that column for high spenders is for people who spend an average greater than 300. That's an example. And then you also want to create another one for high spender loop. So for those who spend high, so we say so whatever if this happens, then we have false for those uh you know for the high spender loop and true for those who spend high, false for those who don't spend high. So you now do the for loop. So you say for I in df index, if df.at and I is average spend greater than 300, then spender loop is true. Then if it's not, then it will be false automatically, right? So and then we just want to extract. If you want to see the whole thing, you can actually see it, right? I think I will demonstrate that in a jiffy. So let me just cut this off so you can see everything, right? So if you run this now, you see you have created new so the ones that were there before up to loyalty program. Now we have high spender and high spender loop. So high spender and high spender loop. So they correspond because it's about basically the same. But here we just want to focus on the few things that really matter to us in this situation. So you see, we just have the average spend. So if your average spending is greater than 300, you're automatically a high spender. So you see all these ones less than 300, yeah, it's false all the way. But 472 is greater than 300, so that's true high spender. 357 true, 269 false, 481, 140, 481 is true, and all that. So because that's the criteria. Once you spend more than 300, you are a high spender, and that is what has happened there exactly. Okay, but then that is looping, right? So first of all, you can see the number of codes is takes 6 lines to write that. But look at vectorization, which is the opposite, right? For vectorization, it is fast and clean. The other one, we said it's inefficient. So it's a solution to that trouble of looping. So we have a vectorized logic which runs in C speed under the hood, and it's cleaner and readable. Always prefer NumPy like operations. Inside, almost all conditional featuring arithmetic, string operations, and math can be vectorized in Pandas. So vectorization saves you from looping. So, and how do you vectorize? In fact, the whole thing you have done is just in this one line. This line too is just to visualize it basically. So what you're now simply doing is df high spender is equal to anytime you have df average spend greater than 300, then that's you have done that. So what we are doing here is just to visualize it, and we are focusing on those three things. So the same thing you did using 6 lines up here, by vectorization, it takes just 2 lines, right? Exactly the same thing, nothing different. And then we move to the next one where we talk about chained indexing pitfall. So that's a common thing that people fall into in Python. So chained indexing doesn't guarantee assignment. What that means is that it looks like a good code, right? What you have in this next cell now looks like it's looking very good, but it creates a copy of the slice, not a view. And assignment doesn't persist. That is, it leads to bugs. So, and when you have a bug in your code, it's going to give error, right? So here now we have uh data frame of gender. When gender is equal to female, want to know the average spend, and we're multiplying the average spend by 1.1. All right. So if you do this now, if you run this, it doesn't give a good result. I mean, it gives error because you can see it's a problem that chained indexing. And the whole idea of chained indexing is saying that you have this component now, which is okay, like you have this one which is complete on its own. Then you now have df again, which also covers that, and you have average spend on it on the other hand. So, and it gives you no one. Okay, this is you have no warning, no effect, right? Like it doesn't do anything, right? So it just outputs an error result. So no warning means that it would have told you that, oh, this thing is not possible. But guess what? Just this two, if you don't do chained indexing, you know, uh, the right way, the solution simply lies in using LOC. So you just locate what you want to do, Okay, so instead of doing df, all that, so you just say .loc is guaranteed to work as expected, and it is safe and explicit. So you just say df.loc. So you're locating wherever gender is female, and you want to find their average spend. And whatever the average spend is, you're multiplying. Star means multiplication. You're multiplying by 1.1. It's more like you're increasing it by 10%, so to speak. And when you run this, that you get the results like that. So everywhere you have a female, so the average spend is automatically, the initial average spend was for the first female, for instance, was 126 or something like that. But here now it's been multiplied by the 1.1. So you have the average spend automatically increasing. Let's look at it again. This is, yeah, the top three are female. So you see that there is a difference. Now the top three are female: 126, 771, 182. Now we have 139, 85, 200, like that. So that multiplication has affected. What couldn't work here has finally worked in this place. So another thing we want to talk about will be memory optimization. Of course, because we are talking about advanced pandas techniques and memory optimization. So first of all, if you want to know how if you want to optimize memory, right? Because space is of importance to you. Like you want to do, part of optimization is that whatever you're doing should take less space, even on your disk, right? So the first thing we're doing here is we want to check initial memory usage. So we are doing df.info. So if you want to focus on memory usage, so instead of just doing df.info and open brackets, you now put memory usage equals deep. So if you if you run this now, so it tells you, I mean, the usual thing. And the memory usage that the memory this thing is taking is actually 9.5 kilobytes right now. Because, we have added other things like loyalty program member. Okay, we add up to loyalty program member. Now we have iSpender and iSpender loop. So now it takes 9.5 kilobytes. That looks like a bit of thing. But if you have something bigger, it can mean a whole lot. So here we are now with all these things. Now we are optimizing memory types. For instance, the loyalty program that was the loyalty program thing, right, is actually Boolean here. So you now say DF loyalty program member as type Boolean. Okay. The gender was categorical, right? I mean, gender was object, so you now say it's category, and purchase frequency before was object. Now you say it's categorical, right? So, so of course you have to be sure you run this. As far as this place is blank, is open, it means you have not run it. So be sure to run it. So enter. So number 13, you're not seeing any results, but whatever you have said it should happen here. So what you have done here is to change the types of these things and see how the memories can be optimized. So take note that we have 9.5 kilobytes up there, and having done this, we can now recheck. So we do the same check again, df.info memory underscore usage is deep. So you press enter. Guess what? You now have 2.6 kilobytes. So from 9.5 kilobytes, for doing this cell 13 now, you have reduced from 9.5 to 2.6. That's so the difference between that is like 7.7 this is 2.6, right? That's 13. This 13 times 2, this is 13 times 5. So 9.5 times that. That's like 7.8 or thereabouts. That's the difference that lies between the two of them. So although it's in kilobytes, right? So you may not really appreciate that. All right. So you can even, a bonus point is you can use dot memory underscore usage bracket deep equals true for detailed breakdown of the memory. So you can just run this. Okay, so it now tells you, okay, you have customer ID 560, age is also 560, so average spend is 560 also, purchase frequency is 347, gender is 286, index, so you are sorting the values now. So gender 286, index is 132, loyalty program. So this is breaking down the memory usage that is going on right there. Okay, so and in this case now, of course, all these things are integers now. So it's giving you a detailed breakdown of the memory usage. Okay, so this should be like bytes now, not kilobytes. This should be like 560 bytes, 560 bytes. Then the smallest taken by all these categorical ones, so all the 770 bytes. So if you add everything together, you should get like this 2.6 kilobytes. Okay, so we also have what is called method chaining plus dot pipe, right? So the benefits are you can have clean, readable pipeline and encourages pure functions and easier to debug and test, right? So you have a modular. So imagine this modular approach now. So you say define, add normalized spend. So normalization usually is you have the average spend divided by the maximum spend. So that bears a bit of resemblance with what we did about normalization when we're talking about data cleaning, right? So so you normalize spend. So you have whatever each spend divided by the maximum. That way you normalize. Then you can also do another function. You say define label young. Of course, def is for defining Python functions. So label young customers, df. So young customers are people, anybody. So we are taking our young customers to be anybody aged less than 30. Okay. So we do that too. And then we also have categorized loyalty. How loyal are the members? So loyalty level means so you're mapping loyalty program member. If it is true, then they are member. If it is false, then they are non-member. And then we can visualize the top 50 in this case. So you see, so we have additional stuff now. So loyalty program member now. So you have true for all these ones. Uh, and that is based on whether it's true here, right? So those are members for true, and for non-member, it's actually false, like that. So, but imagine instead of doing this modular approach, we are talking about optimization, right? So that same thing that you did up there, you could just do it in, I mean, how many lines did you use up there? This is like, okay, if we remove the spaces, that's like 10 lines. But even if you can save one line, that's a lot. So here we have 7 lines saved, right? And we can still, yeah, we have about 7 lines saved, right? I can even still save one more line here by just bringing this closer here, and it's still the same. In fact, I can still go further and save one more line, right? Because it's still, so we have 5 lines now, doing exactly the same thing that we did up there, using the dot pipe thing, this dot pipe instead of this modular approach. So so dot pipe, you just say dot pipe add normalized spend, dot pipe label young customers, dot pipe categorize loyalty, basically, and that's just what you are doing. So and then if you run this, you see, it just gives it to you. Like you see all the member is young and all that right there, you know. So that goes. So you can use assign to do inline operators. So average spend and all that. So you do the same thing. So you can use assign. So it's just a df.assign spend per age equals lambda. So average spend divided by age. So that's spending per age. So you now have that new column now. So it's like whatever age 56 divided by their spending, that gives you the spending by age right there. So this is the normalized spend that we got previously. It's young, but this 56-year-old is not young. That's false. 25-year-old is young. That's true because of the criteria that 30, anybody less than 30 is young. So 30 upwards is not young. So that's why it will be false. So we come to 9.7 where we talk about timing and profile coding and profile code. So we also want to optimize time, right? When you are doing your stuff, so you want to optimize time. So in Jupyter, you can use percent time IT to, so like you want to find an average now, you want to know what time that takes, and then you want to visualize the DF now. So by the time you run this, takes some time, and then it comes up with this 22.7 microseconds plus or minus 3.06 microsecond. That's like the error possible. And that happens per loop. So you have the mean plus standard deviation. So you have an average of 22.7 microseconds, and then you have an error, possibility of error of plus 3.06 microsecond, like that. So for 7 runs and 10,000 loops each. So that's basically about timing. So it shows you the timing that average spend. So now we have found average spending, right? So find average spending. So that's how much time that takes right there. Okay, so we also have this other one, super jump, which may not be so much of interest, but let's talk about it a bit. So profile entire script, memory profiler and line profiler. So you have to install memory profiler and line profiler. This may not be so much interesting, but it's okay. Maybe you may get to some point where you really appreciate the need for this. I had installed it before. That's why if you are installing it for the first time, it takes a bit more time and then it runs. And then you can add decorators and also outputs and see what happens there. So all this you can just they are not like big deal. So you can now run this script again too. All right. Before we now go to something a bit more interesting. So that has run. So we go on to real world example use cases. So what if you want to analyze spending by frequency? So it means that you are grouping the data frame by purchase frequency, and then after grouping that, you now find the average spend based on the average. You want to find the mean average spend and the count of the average spend, right? Based on purchase frequency. So if you run that, you see that for those who, for frequent purchasers, the average spend is 279.85, and they are 28 in number. For occasional, uh, for those who are uh, occasional customers, right? So the average spend is 255 and they are 19 in number. For those who rarely come, right, the average spend is 273. They hardly come, right? But then when they come, they spend big and they are 23 in number, like that. So we have their mean and their count based on purchase frequency. And we can also visualize this using a bar plot as you have it here. So that tallies, right, with the average spend. So the average spend of 279, this thing is around 279. Occasional is like 19, it's like 255, somewhere around here. This is 250, and then you have 273, which shoots a bit, which is close to this 279, right? So you see frequent, occasional, and rare purchase frequency on the x-axis and average spend on the y-axis. So that's some visualization. Though after this video, I'll begin to talk about data visualization for sure. And then we have loyalty distribution. How do you also want to see loyalty distribution? So loyalty program members, you want to count those, you know, you want to count them. And if you run this now, you have uh and you are normalizing. So normalizing means divide by the highest. So you can find it in terms of average, in terms of proportion, all right, or fraction. So loyalty members, so 0.57 of the population is like they are not loyalty program members, and 0.42 are loyalty members. So this is like 57%, and this is like 42.3. And this pie chart here shows you that, so we want to plot a pie chart. So if you press enter, so you see loyalty program members 42.9%, non-members 57.1, just which tallies with these proportions we have seen right there. And then we go for the young frequent spenders who are high value. So it's more like once young people, like people less than 30 who come frequently and they spend big. All right. So we are putting everything together. So young spender, frequent purchasers, high spenders, and so true and false, we have all of that there. So um so we want to, so this one just extracts. So I mean, this combines all of those kind of people, right? Um, like that. So we have, what are we even looking forward to now? So we have DF of all these people alone, and then uh this is high spend loop. So it's young, false. So spend per age, like that. So we want to see all these young frequent spenders who are high value. So we extract only those out of the whole table. But let me see, why is it that we have this many? Let's see. Okay, we still have 70 rows and 12 columns. So spend per age is 2.43. What does this give us? It's young and purchase frequency and that. Okay, so we have that way. Trying to see what the result is for this. So 32. Okay, this person is, so this is 25, for instance. So it's loyalty program member false, high spender false, high speed normalized is 0.3, is young true, loyalty level is non-member, spending per age is 7.70, like that. Okay, so that's what the result looks like here in this case. Then we now have the summary table. Of course, this is like the summary of everything we have been doing so far. So vectorization. So for bad example, when you loop using AT, it's not as efficient as when you do vectorization. Chain indexing, where you have this when you have these two brackets separated, so you can just use LOC and then open up the brackets and equal to the value you're looking at. Memory optimization, of course, we saw changing object to category, changing integer to boolean, and float to integer 32. so flow 64 to integer 42 if possible. That saves some space. So you also have method chaining where there's a long procedural code and you can do a modular reusable with pipe, right? And for profiling, you can have no time memory insights. So you can use time to know the timing, and then you can use memory profile and memory usage. Now, this may be a bit boring for the most part, but I mean, you might find it useful one day soon. So with this, I come to the end of this video on advanced Python pandas technique and optimization. Starting from the next video, we'll be looking at visualization. I think we'll start with Matplotlib, then we'll go to Seaborn, and probably I'll still go to Plotly. There's Bokeh, there is Alt Air and everything, but so far my top two are still Matplotlib and Seaborn. All right, so maybe I'll just show Plotly because it's good for things like widgets and everything. I don't know if we go that far though. All right, so let me know how helpful this video is for you. And if you want me to teach a topic, teach on a particular topic or solve a particular problem, or you have a data set, kind of data set you like me to work on, whether you have the data set to send to me or just let me know about the data set, I can make it up and then try to work with it and do some analysis with it so we can draw some insights. So if you have subscribed to the channel, thank you. If you have not, you definitely know you are missing already. So you want to subscribe right away and hit the notification bell so you can always get alerted each time a new video is released. And be sure to like and share so that more people can have access to this great content. Till I come your way again, keep doing data right. Bye.